Good afternoon. So I sent out an email yesterday about student evaluations, and you should all fill out student evaluations. And yes, I do read them, and I don't read them until after all the grades are submitted, but I do read them, and I do appreciate the feedback, and I do make modifications to the style of the course, etc., based on that feedback. But here's what's going to be different right now. There's about 50 students enrolled in the course right now. I know from previous experience, even if I keep pestering you every lecture and really send multiple emails, 20 of you will feel guilty enough to actually do it. So I'm going to try something different, which is I'm going to say if. So I get a little indicator that tells me exactly how many students have filled out student evaluations. I can't see them, but I get to see a percentage of the class. So when, like I said, there's about 50 students in the course, a little more than 50. When I see that 40 students have filled out student evaluations, like I said, I'm going to get 20 no matter what, just from people doing, wanting to give me good feedback, and it's just ingrained into them. That's great. But if I can get 40, the moment I wake up in the morning and I look at the number and I see 40, I will write out solutions to the first two midterms and post it on CCLE. Okay? So if it never reaches 40, you will never get those solutions. Okay? But if at some point it reaches 40 or more, then I will make that a high priority to write out solutions and post it on CCLE. And off you go. Okay, so we left off last time really exploring and what I think is the power of template programming. As you also saw, whenever you have a compiler error with templates, it can generate these massively long list of errors. So in that respect, it's kind of there's a trade-off with working with templates, which is more or less indecipherable error messages. You kind of get the hang of it after a year or so. Okay? But at least initially, that's kind of a big kind of put-off. The good news is that in the next few years, it should be getting better. There should be more structures put in place where it's very natural to put in just a little bit of extra structure, and the error messages will be a lot easier to read. At the same time, templates are the most powerful, in my mind, the most powerful tool that you have at your disposal in C++. So let's see why. So remember, when you make a template class, for example, or a template of anything, I think we did points, right? We made points a template class. What this means is there is no longer a class called point2d. It ceases to exist. It's kind of like a vector. Can you just have a vector? No. It has to be a vector of ints, or a vector of doubles, or a vector of something. You cannot just have a standalone vector class. In principle, you could. There's no reason why you couldn't make your own class called vector. Okay? But the standard library only gives you the ability to create a vector with a certain data type. Now that's what we've done here with our point2d class. Whereas before, the idea of class point2d was a fixed notion in your mind with two x and y coordinates of data type double. What I did last time in class was I said, all right, let us make the idea of point2d cease to exist and replace it with instead the idea that it's not just about the name point2d, but it is about the name and the data type of which the data points are being stored. Okay? So it is a point2d of ints, or a point2d of strings, or a point2d of doubles. There is no more this notion of point2d. That has good sides and bad sides. Now, the reason why you have to specifically refer to a class of, for example, point2d of a certain type is because, if you recall, templates are not actual functions or classes. They are merely the ability for the compiler to generate code with that data type filled in. So when I create, for example, point2d of int, and I create a point2d of double, there is quite literally no relation between these two class objects. All right? There are two completely separate class definitions contained in the source code, or in the code that's generated by the compiler, but there is nothing implied about any connection between these two classes. They have two completely separate class definitions generated by the compiler. You will never see them in your code, but the compiler generated two different classes and then created two different objects of those classes. Okay? So unless you specify that there is a connection between, point2d of this type and point2d of another type, there's really nothing implied about the objects are really just completely separate types. Question?
So when you type in like point2d of int, so the compiler goes and sees that you put an int, and in places like in your class definition you have template type name t,
Mm-hmm.
so then it assigns t to int.
Yep.
Right? And then so everything, like the t within the class definition is consistent with itself, right? So once the t has been defined by you putting int, then everything that has t will be like replaced by an int, right? Like the x will be an int, the y will be an int. Is that right?
Correct. Wherever you see t, when I do point2d of int, you can think of it as this tells the compiler how to generate a separate class with int plugged in for t everywhere. Yep, and then?
So separately, like for the member functions you define later, you do like template type name t separately every single time, and those t's are not explicitly linked to the t that you did when you defined the class, right?
Correct. So there's no implied relation between this template type name t and the class template type name t. The real connection here is when the compiler says to itself, I need to create a class of point2ds of ints, then it says, and this is the key, it will only create those member functions for which it needs. This is the beauty of it as well. So like I said, you create separate classes for everything. But if you don't call the move function for the point2d of ints, it will not create that function. Okay? If you create it for the point2d of doubles and you call move on it, it will only create the move function for doubles. What that means is there is I don't want to use the term decoupling because that has so many other uses, but there is a separation here which says for a class definition, there's a template type name t, which inside locally is referred to as t. But then, let's say it needs to create a function called move. So let's go to the class definition. If in the class definition it says, hey, I need to create a move function, then it goes to where that template is defined, and it says, in my class definition, point2d of int, I need a move with two int parameters. It then goes to that function and then says, oh, here's how you create this function template tells you how to create a move with any types of parameters. So for ints, we're going to create just the one for int. So it's completely separate kind of, they're connected in the sense that if you want to be able to create a move of any data type, you have to have them both templated. But it's separate in the fact that the type name t up above and the type name t down below where you define the function, those can be called whatever you want. And again, it's just like defining a function f of x and then saying, what's the difference between f of x and f of y? Well, really the issue is, what is the transformation of input to output? And then x and y, these are just the dummy variables that allow you to kind of replace x with, say, x squared or y with y squared. So it's kind of like a function in that respect, except it's giving the compiler the tools it needs to generate whatever function it needs of whatever type. And usually, most template functions that I've been working with are defined inline. In other words, if you have a function called move, which is a member function, and it's templated, usually you do everything inside the class definition. It makes the code easier to read, it makes it easier to understand and kind of connect together. The downside to that, of course, is that when it comes to commenting, it really muddles up your code because you have to put all the comments. If you define a function inline, then you have to include the comments for it as well. So for example, here, I've got two functions that are friends. I really should have comments here and here. And like I said, for some reason, I forgot to look this up, but I'm not able to declare the friend functions and then define them, still within the same header file, of course, but I can't think of why I shouldn't be able to do that. But I do know this always works. You make all of your friend functions inline, and then it compiles just fine. Good question. Yeah, question. When you declare, do you need the keyword inline in order to declare it inline? The answer is if you define your function locally, just all in one place, inline is implied. If you still want to make it inline, you can still do the declare and then define, but then you have to put in the keyword inline to tell the compiler to make it inline. But the keyword inline is really more of a suggestion at this point anyway, so you do need it if you're going to put everything in your header file. Then you need the inline keyword, because otherwise it will look for the definition in the .cpp file, unless it's templated, in which it doesn't do that. Okay, sorry, that was a complicated. It was more complicated than I intended. For templates, you don't really need the keyword inline. But if it's not templated, then you should probably throw in the keyword inline just to emphasize that it is inline. Yeah. But there's no notion of a non-inline. Everything with templates has to be inline because you're generating the code. Okay, so again, I showed you point 2Ds, and then I put 2 and 2 together, and I said, oh, wait a minute, I have a fraction type. And I didn't template fraction because, as you saw, there were a lot of member functions I'd have to template, and it just would have taken too much time. So like fraction A, 1, 2, fraction B, 3, 4. And then I can do what's really cool we saw last time was point 2D of fractions. And then I can input A and B, like so. And then I can even see out pt frac. And the reason I can see out this is because it goes down the chain. Okay, in the call in the overloaded operator less than for a point 2D of fraction type, it needs to be able to call operator less than on the fraction types, the underlying types. The fraction class has the operator less than overloaded for it. So it just calls the functions as it needs them. And as long as all of your functions have the right operators overloaded, you can still get this very nice and natural notation. So there's my point 2D of 2 fraction objects. Okay? And again, how many different point 2D classes have been created using this code? 3, exactly. 3. Okay? Each one is separate and distinct. And similarly, if I call, for example, pt.move, only the move for the int class will actually be created. None of the other ones will because they weren't invoked. They weren't called. Okay? Okay. Then I added in the extra layer, which was I thought was really cool, was this binary tree templated first step. And what I meant by first step was that it had one template parameter, which is the data type of the node. So instead of an int or a string, we said, well, it's going to store objects of type t, and we're going to specify what that is. And again, as long as we have all of the other operators defined, we can create things like a binary search tree of type point 2D of fractions. And I can insert that, and I can call see it on BST. Oh, no, I can't. I have to call print on it right now. This is the class from the book that I didn't extend with all the operator overloads. So, but I can call .print. The reason is because your book doesn't do the operator overloading until after it covers a lot of this material. So, and there you go. So this is the point 2D move. It's still not quiet, but the first printing is from the object itself, and the second one is from printing all the elements in the binary search tree. Okay, so the reason I called that one first step is because the second step is to use the binary search tree class, which also sets policy. And so you'll recall, oh, that's a weird, well, just ignore that. Can you just ignore that? Well, you can for now because I'm not calling anything. But okay, let's just take a look at this. I have a tree node class, 2 template parameters. One is t. And what I'm doing here with the second parameter is I want the default behavior to still stand. I still want to use operator less than if I don't specify a second argument. This is exactly what the set container does. And so by doing an equals less of t, what we're saying is there is a class called less, templated for type t, which will invoke the less than operator when an object of that type is being called, using the parentheses operator. Okay? So we're saying, in general, you're always going to invoke the open close parentheses operator, but by default, we have this built-in type in the functional library which already has that overloaded, and it just calls the less than operator between those 2 types. So that gives us our default behavior. So let's see if this actually works. And again, I think I just took this from your book, too. So in chapter 16. Yeah, that I knew it was going to cause some error. Binary search tree undeclared identifier. Let's see why. So I need to number include functional. Okay, it doesn't like my binary search tree. Oh, I think I put it in a namespace. Okay, that's. Oh, wait. Oh, I did. Okay, hang on. Let me get rid of this. Don't worry about what names. You know what a namespace is, but don't worry about it. Okay, here we go. BST unknown size. Now it's just complaining about the size. No appropriate default constructor available. Okay, so now we go in here and we look at the class definition itself. And excuse me. Here we go. So that appears to be the default constructor. Oh, I didn't do the default template parameters everywhere. Okay, so that's probably why this is giving me trouble. Okay, so here we go. Let's copy this over to. Oh, wait. Will this work? This might. Oh, yeah, it works. Okay, cool. All right. So I do this. Okay, so everything works the way it did before. It's a completely different class, okay, but it works the same. So now what I'm going to do is I'm going to insert another couple more points like I had before. So let me just get rid of this. And that's what this was here. Was down below here. Okay, so this is the same exact code from last time. Okay, so I print out a bunch of fractions, and it's doing it in the radius, is like the distance from the point 0, 0, and I can change it to sort them by x value, for example. So if you look here, you go from a fourth to a half to a fourth to a third to 5/7 to 3/4. If we want to insert a different order, then we do comma my order. I think x was in this. If you look up top here, in this file, my compare, and that just calls the less than operator. Let's call this my compare x. Okay, so I'm going to input a templated class type, my compare x, or let's say my point order x. And we'll do capital X because this is going to be different from the non-templated one. And we're going to take 2 const t references, and we're going to return dot x less than dot x. Okay. Now this is going to be a little bit tricky. No, it shouldn't. It is going to be a little tricky because we have to do one little thing. Yeah. Okay. We're going to take this class and put it in the points.h. and where I have the other ones defined. So down below here, I still have them, or I deleted them. No, I got rid of them. Okay, so we're going to put this here up above. Okay, and then what we're going to do is we're going to make this a friend. Friend class point order x. Okay, so it's not just, okay, this is the key. It's not just every single class that is a friend of the class point2d. Okay, it's only the point order x class which has the same template parameter as point2d. This is the key distinction, right? So there are as many different point2ds as there are input parameters, and there are as many point order x classes as there are input parameters. And the friendship relation is only between classes with the same template parameter. Okay? So, point2d of double and my order x of int, there is no friendship relationship between those two classes. Okay? Yeah. Okay, so my order x, so point order x is what I should put here. So, and it's not just point order x, it's point order x of which data type? Point2d of fractions. Okay? Why can it not access? Let's see. Points. That's why I made it a friend. Let's see. Okay, well, I can make a function called getX and then make it work, but I don't want to waste too much more time on this. But you'll see how. Well, let me just do the one thing you shouldn't do, just to show you that this works. I'm just going to make these public for now, just to kind of show you. Again, you can spend like 5-10 minutes doing it. I can't do it in front of the class right now, but that's what you would do. You would say, oh, okay, what's the subtlety here? But there you go. Now, if you look in the order of x, how did it sort them? In increasing x values. Okay? And all I did was just give it a different set of parameters, which were not values, they were class types. That's what's so profound about this. Okay? All right, so enough about this. Are there any questions on this? Yeah.
When you print it and you call the operator less than of the template, is it printing point to the template or the template printing again?
Yes, so you go see this print nodes function. It's calling cout on data. Okay, so BST goes to print, and then at some point it calls cout on data. Well, what is the data type of data? Point2d of fractions. Not just point2d, right? Point2d of fractions. So now we go to the point2d template, which means, and ask ourselves, do we have a way do we have an overload for the operator? And you say yes. If you wish to print out an object of type point2d of fraction, it will use this template to create a function which then calls print on an object of type point2d of fraction. Now, what does the p.print function do? Let's go to the print function locally here. And it calls cout on, the quotation marks, but then on x and on y. Well, what is x? X is templated of type t, which in this case is of type fraction. So then we go to the fraction class, and it says to the fraction class, hey, can you give me a way to cout an element of type fraction? And fraction says, whoa, I'm an actual class. I'm not templated. I already got that. Okay, it's already in there. Where is it? It's somewhere in here. There it is. How do I output that? Well, fractions call f.numerator, f.denominator. What are those members? Those members are just ints themselves. And we know how to cout ints. So it really, you just have to unravel it. And as long as each piece knows what to do with the operator less than, you can continually pipe it down the chain. Okay? So that's why, again, it's a higher level of abstraction, but there's a power there because of it. Because as long as each piece locally can do what it needs to do, you can synthesize them all together. Okay? Yeah.
When you define the binary tree templating type,
Yeah.
I think in the class definitions, there's like you wrote the templated version name of the constructor, which I thought you said that since the constructor is a function with a name, you're not supposed to use the.
You mean here?
No, in the definition itself, I think. Like, yeah. So,
Oh, this, yeah.
so
It's implied, so this is not necessary.
you can just write Freenode without that.
Yes. This, okay. Let's see. The reason why this is implied is because you might want to write a template function inside which has a separate template parameter value. Okay? Say f. And so you may want to tell it that this function here is not calling the function that would be invoked with t, but of a different parameter f. But if you don't specify anything, then it, especially for the constructor, it knows that locally speaking, it assumes you're talking about the tree node class with those two parameters. Especially for a constructor. With a constructor, there's no, there's no choice. There is only one option. That syntax above emphasizes the role of t and compare, but it's not necessary at all. Yeah. In fact, that's the advantage of defining all your functions inline, is that you don't need to continually write out the template parameters. Whereas in the definitions below, still in the header file, you always have to write of t comma compare everywhere. Okay. So now that I've beaten templates, I haven't even beaten them to death. You just scratched the surface of templates. Let's, we're just going to go over the topic of priority queues on this, because at a previous time when I taught the course, I taught things in a little bit different order. So priority queues and constant iterators, we'll just go over those again to make sure that we understand what I mean by that. Okay. Remember that this is another type of way to store a collection of objects. And the reason I wanted to wait to cover this is because when you see the syntax, when you see the way the code is written, now that you understand, at least on the surface, how templates work, you should be able to say to yourself, could I write my own class to do this, and can I template that class in much the same way that the standard library utilizes templates? Okay, so while we discuss the actual code, always have that in the back of your mind, which is, wait a minute, some human being wrote this code and put it in a library that was just really good and became standard. There's no reason why I couldn't do the same. And by I mean all of you. Okay? So think about how the implementation details actually may have what would be involved. So a queue is like a line, and we have a queue data type in C++ in the standard library. Okay? First in, first out, just like a line at like grocery store. A priority queue is different. It's a way to quickly access high priority tasks. For example, at a hospital emergency room, you are actually treated in the order of urgency rather than entrance. Okay? So if you come in with a headache and someone comes in with a gunshot wound, they don't exactly take the next number. Okay? There is a priority associated with insertion. Very much like in a binary search tree, you insert things and it gives you an order. Okay? It orders it not based on the order when you inserted it, but by its value. Okay? So a priority queue is the same idea, except it's more of a top-down sort of concept. In other words, a heap. It's implemented precisely as a heap. In other words, here's why. The idea of high priority should sound familiar because it's a heap. And the reason why is for the following. At a hospital, if you wanted to keep track of patients entering and exiting, you don't want to store them in the order in which, necessarily in the order in which they arrived. You probably want to store them in the order of severity. And then when a doctor becomes available or a hospital room becomes available, you then take the highest priority person, pop them off the container, and then shuffle everybody up accordingly. Okay? So it's about how you want to insert and take away or erase nodes from the structure. That determines how the internal structure, how the nodes are stored internally. Okay, so a priority queue is stored precisely as a heap, i.e. a binary tree, not a binary search tree, but a binary tree with some imposed structure on it. Okay, so I think this is a recall, right? Because we already knew how to insert. We know how to insert nodes in a heap. Remember, to insert a node in a heap, you add in, a heap is almost complete, so you add in the next possible location, and then you start demoting elements until the heap property is satisfied again. You can erase random elements from a heap if you want, but the most natural application of a heap is, well, a doctor or a room is available. Take out patient with priority queue value of 80, and then you're only ever going to take out the root node, and you're going to shuffle everybody else as a result. Okay? So rather than show you how to remove any random node, I'm only going to demand you understand how to remove the root node. And here's how you do it. You replace the root node with the most recently inserted node, and whatever the contents are in that node. So the 4, this node location is the most recently inserted location. Whether or not there was a 4 before doesn't matter. There's a 4 there now. So what you do is you bump the 4 up to the 80. And just like when you insert something first and then you demote, and then you promote or demote or whatever, you do the same thing. Now you demote the 4 while keeping the heap property. So you look at the 25 and the 57, and the 57, maybe we did go over this before, so maybe this is still review. But the 57 demotes the 4. It can't be the 25 because the 57 has to be larger than everything else. And then of the 2, it's the 43 that wins out. Okay? So side-by-side comparison. So this is code from your book. Your book's code is not templated. Okay? The standard library is. Now, you should, in principle, and because you're taking a course in Pick 10D, be able to, for example, convert the code from the book, which doesn't use templates, at least in this section, and you should be able to convert it to templatize it or make a template out of it in such a way that you can write this code verbatim. Okay? Aside from priority queue, replace it with heap of int. Okay? So, but it's the same idea, which is you insert elements, and it doesn't matter the order in which you've inserted them. What matters is the highest priority elements go on top, so what gets printed out is 27, 12, 9, 7, 3, 1. And on the other side, there's a lot of duplicates there, but it's 9, 4, 3, 2, 2, 1. Okay? So similarly with other containers like set, map, and priority queue, set and map, a priority queue needs to be able to sort the objects. Okay, so it has to have the less than operator defined, or it has to have the ability to sort the objects using an input of type like point order x or something like that. Okay? Now the reason why I'm going through these slides is because the more old-fashioned way of setting policy is not from a class object, it's actually from a function. And I didn't go over how to do it with a function. I only did it with classes because that should be your default. You should be very comfortable creating a new class and overloading operator, open close parentheses. But I wanted you to see the syntax for if you wanted to just define a function which compares two objects of those types. Just how incredibly unwieldy and it's a horrible set of notation. It's valid syntax, but I want to convince you that the way I've presented it, at least initially, is preferable to what I'm about to show you. Okay? And in case you ever see this code written in actual production code, you know that it exists, it's a thing, it's valid, and that you should probably not repeat it. Okay? So, like I said, you have to have a less than operator defined, But as we saw for if we are putting, say, points, if we want to sort points and all we have are the pointers to those points, there is a less than operator already defined for all pointer types. And it's probably not what we want. Okay? So we either have to create a class which overloads the operator open close parentheses with two point2d pointer arguments, or we can do what I'm about to show you here, which is through what's called a function pointer approach. So let's just recall what the idea is. We have a bunch of points, and maybe we want to sort them in the order of their distance from the origin. Okay? So maybe we have some result we're trying to test out which says that, oh, if you put some random points on the plane in some fashion and you sort them from radius, then it should have this property. Okay, so we want to create a bunch of points. They're going to be of color point, weighted point, just a bunch of points. We want pointers, basically. Okay? So we're not going to want to rely on the internal less than operator for objects of pointer type. So here's what you can do. Okay? So rather than create a class object and overload the operator open close parentheses, you can just create a standalone function called, say, less than, and give it two point2d pointer types. Okay? Now, they have to be of const or by value. Okay? You can't put in a point2d pointer reference because sets, priority queues, they don't allow you to modify the contents once they're inserted in the container. So if you're going to call a function with those arguments, with those nodes as your parameters, you have to either make a copy of them, so there's no danger of overwriting the values, or you have to pass in by const reference. Okay? For pointer types, making a copy doesn't matter. Pass in by value, it's not a big deal. Okay? For everything else, any class object, you'd want to pass in by const t reference. But basically, what all I decided to do was ignore the string, ignore the weight, just dereference them, get the sliced object as a point2d object, and then compare them as two point2d objects. Okay? I've already overloaded the less than for two point2d objects. All my less than function is doing is it's polymorphically accepting any point of point2d, color point2d, or weighted point2d type, right? Because it's polymorphically pointing to one of those. But then I'm dereferencing it, and that's slicing it to give me precisely a point2d object. And I already have the less than operator defined for two point2d objects. Okay? So I'm basically slicing off the string or the weight, and I'm just saying, all right, call less than on the underlying point2d object type. But this is the syntax for how to create a priority queue or even a set. For set, it's the exact same syntax. Using point2d pointers. And then again, you might have said to yourself, well, you had to create a class. You had to overload the operator open close parentheses. Is it really better to do it that way? Why don't we just input a function directly and have it just create a standalone function and have it call that? Well, the trade-off is, yeah, you have a much kind of more elegant looking, more traditional looking C-style coding scheme, which is a very simply defined function. Here, maybe you put it all on one line to make it look even slicker kind of thing. But then creating the object is just a nightmare. Okay? So we're going to go through each piece of that one by one, but it's exactly the same as template. It's just a template. But just trying to understand what this syntax is telling you, I think, is more obtuse than creating a class and overloading the open close parentheses operator. Okay, so here's how it works. There are several ways to create an object of type priority queue, depending on the template parameters. So for sets, maps, they all follow the same basic paradigm, which is the following. First, you have to name the container. Okay, that was easy. Next, name the data type. This is like T in our binary search tree. This is the simplest form of template of type T. I substitute that data type in when necessary. Now, the problem that comes in next is you have to specify for priority queue, not for set or map, but for priority queue, you have to now specify what's called the underlying container. it's always going to be vector of whatever was here. Okay? So if you just want to specify a priority queue of point2d pointers, you just stop and let all the defaults take place. But if you want to set the policy, you have to not only include this parameter, comma, the policy is here. You have to also include this intermediate step of saying, oh, store them internally using a vector of point2d pointers. You're not going to use anything other than vector of point2d pointers here. And then you can get to the actual overloaded type, which sets the policy of how to compare them. Okay? So this is how priority queue differs a little bit more from set and map. Okay? It's that you have to, if you want to set the data type and the policy, you have to also specify this intermediate way in which it's going to store its collection of elements. Okay? And there's only a certain number of containers you can use. I don't think you can use a list here. Yeah, I'm pretty sure. No, you can't use a list here. You need what's called a random access iterator, which you won't learn until 10C. But if you take 10C, it doesn't matter. But vector is safe here. Now, this is the part where I think it just gets too annoying. It's too cumbersome, not intuitive at all. Which is, what is this even? Okay, this is saying pass in an object of type function pointer. Basically, okay? So let's see what this means. The star here means it's going to have a name. That's the name. It's going to have an output of type bool, right? Less than returns true or false, depending on whether the left-hand argument is less than the right-hand argument. And it's going to accept 2 point2d pointer arguments. So once you understand what it's saying, sure, it's not cryptic, it makes perfect sense, but you wouldn't want to spend all day reading this type of syntax. Okay? It's not very intuitive. So again, this specifies the input-output structure of the comparison function. The good news is you only need to really know this once, and then you can create a function called less than, you can create a function called less than 2, less than 5, my other less than, this other less than, this other guy's less than, and you use the same declaration here and here with different variable names, and you just input the particular function you wish to invoke when it needs to do the comparison. Okay? So the key is that all of these are inside the angle brackets. Okay? That's what makes this really sort of ups it a notch. And then the name of the object, and then the name of the function. Okay? So that's when this is now what it kind of looks like. Okay? If you want to do the same code but with the new less than function for the ordering, this is how it's going to look. Everything looks exactly the same except that top call, the name of the class that PTRS is a member of, that's just a monster. Okay? So that's why I shy away from this syntax. Okay, inline functions we know. Just remember, inline is a suggestion, because that question came up. You can declare a function inline that doesn't get inlined. You can not declare a function inline that does get inlined. It merely suggests to the compiler to take maybe a closer look. But nowadays, the compilers are really good at these things. So it's more about getting everything syntactically correct, and the compiler will do a lot of the heavy lifting. Member functions, inline. Inline is implied. Remember, if you create the function inside the class definition, you don't need the keyword inline. It's implied that it's inline. Okay, so just keep this in mind as well. If you declare a member function const and you try to create an iterator that's not of type const, you may get an error because you're creating an object which has permission to access elements and change them. So if you want an iterator that can only access but not modify the contents of the container, then you can use the const iterator data type. I think I demoed the const iterator. No, not maybe it was. Oh, it wasn't for you guys. It was for 10C, I think. Yeah. But anyway, there exists an iterator type, just like the regular iterators. You just put const underscore in front, and it gives you an iterator that can access but not modify the contents to which it points. Okay, so I'm going to, in the last 4 minutes, introduce a new class, a new templated class, and then for the next lecture we're going to go over it because it represents a different way to template. Yeah. So this is actually lecture 27. Okay? So remember how I talked about how you don't have to do that binary arithmetic section anymore? Here's part of the reason why, but mainly it's because it's annoyingly detailed topic, and it was the least favorite topic. It's the most memorable topic. If you ask other students who took 10B, that's the most memorable topic from my course. But I decided to move away from it for this quarter. And here's part of the reason. There is actually a container in the standard library called bitset. Guess what bitset does? It stores a collection of zeros and ones. Okay? So now it's templated in a very weird fashion. What is it? It's templated not by a data type, but by an int or a number. So int maybe, definitely by a number. And a number is different from a data type. Okay? So it's templated by a value rather than a data type. That makes it an inherently different type of template structure. It's the same idea, but it's what's called a non-type template parameter. It's not a type, it is just a value. Okay? But what is it? Why do we need that? What does that parameter do? It tells us that we're going to store exactly 4 bits, 4 0, 1 values. And because this is part of the standard library, they've done it efficiently. Okay? But there's some really cool things you can do with this bit set. So for example, you can set individual values equal to 0 or 1 using the random access operators. That's pretty straightforward. You can also convert to string or unsigned int. In other words, you can convert this to a string of zeros and ones. So there's some internal representation, and you can return a string so that you can print it out, for example. Okay? But you can also, I'll come back to that in a minute. You can also create a sequence of zeros and ones based on the binary representation of an integer. Okay? Now, I did not go over what I meant by binary representation of an integer this quarter. Some of you may know already, some of you may not. You don't need to know how to compute it. All you need to know is the following. Every integer can be uniquely represented in binary. Okay? And what this bitset container will do is it will go in both directions. If you know its binary representation, it can give you the corresponding unsigned int type. And if you know the value, like 120, and you want to unlock the binary representation of that integer, then even without knowing anything about binary arithmetic, this container will facilitate that conversion. And you don't have to know how it actually works. This is the evolution of modern programming in my view. It's about understanding the main concept or idea, not worrying about the details, letting somebody else worry about the details, and just figuring out how do I unlock that functionality so I can use it. Okay? That's sort of my philosophy on programming, especially for non-computer scientists and engineers, is these are tools that you just want to know how to unlock and use efficiently and quickly, and then move on with what you'd rather be doing. So we will start with this next time, and one of the last topics we'll go over is how do you template using a value or a non-type template parameter rather than just ints, doubles, and class objects in general. Again, reminder, as soon as 40 students fill out evaluations out of the 50-some registered in the class, I will start writing up solutions to the midterms and post them on CCLE. Okay? Like I said, I'm going to get 20 just by coercing you verbally and really encouraging you to do so. But if you get it up to 40, I will write up solutions. Okay, I'll see you on Wednesday.